explain this vector identities. Okay.
Okay.
So here given first del cross del phi is equal to 0. So we know that del phi is a gradient here, right? So you can write del phi is equal to del by del x I, del by del y j, and del by del z k, and phi is the function here, so I can write phi with each. So this is the gradient. Now this gradient we have to find the curl. So you can write del into del of phi. This is the bracket. So del is what here? This one, and del phi is gradient. So when you are doing the cross product, we should do the determinants I, j, k. This is the one vector which is del by del x, del by del y, and del by del z. Similarly, the another vector is del phi by del x, del phi by del y, del phi by del z. Now you find the determinants I times of this into this. So we become double differentiation of this is already del f by del z. If we differentiate once again with respect to y, so it becomes double differentiation of phi with respect to y and z minus this one del f square of phi del y del z. So it's become del z by del z del y, but anyways you know that yz and del y is same only, so it will get cancelled. Similarly for the j also, similarly for the k also. Number second identity is given here. If divergent of curl of f that equal to 0. Divergent of curl. So also we can write mathematically the divergence of curl of a, which means del cross of f, that should be equal to 0, because this is the curl and this one into if do then becomes here divergence. Okay, so we know that. Now we can write it here. We know that we know first f is equal to any vector. We can assume here this is considered like a1 of I, a2 of j plus a3 of k. So if you find the curl here, what to write del cross f is equal to I j k del by del of x, del by del of y, and del by del of j. And this is the vector which is a1, a2, and a3, because we have considered this a vector is a1i, a2j, and a3k, because f is the vector here. So if you find it, this one here, I will get it here, this into this, cancel. Del of a3 by del y minus del of a2 by del z minus j times of this one is a cancel. Del of a3 del x minus del of a1 del z plus k times del of a2 del x minus del of a1 del y, this one. So this is del cross f. Now we have to find divergence of this one here. So I can write del dot del cross of f is equal to del means is del of del x I, del of y j, del of del z k times of this vectors four things, which is given here del of a3 minus del of a2, del of a3 by del of ay minus del of a2 by del z I minus del of a3 by del x minus del of a1 by del z and plus k times of del of a2 by del x minus del of a1 by del z. Getting here? So now we have to do two vector is multiply is given with the dot product. So you multiply I, jj, and pk together. So this one if you do with respect to a, so you get with del of a3 by del x del y minus del of a2 by del x del z, because is already y, you are differentiating again with respect to x. So this one is already z, you are differentiating with respect to x. So this one minus this into this del of a3 by del x del y del x, minus minus become plus here, so plus minus minus here, this is also plus minus minus, so here minus minus become plus del of a1 by del of y del z plus this into this. Del of A2 del z del x minus del of A1 del z del y. Now you check out anything cancel this A3 and A3, A2 and A2, A1 and A1 all cancel here, then becomes 0. Identity 3 if given here, curl of A. Curl of A is equal to, that formula will comes here, gradient of divergent of A minus del square of A. Okay, this one. Yeah, mathematically you write curl of A, right?
Yes, sir.
A is the vector here. That is equal to gradient of divergence of A minus del square of A, right? So first we have to find this left hand side here. Curl of A is already we know that. Del cross of A I can write it. A is the vector here. Okay, like I can consider here.
Yes, sir.
A vector A1 of I plus A2 of J plus A3 of K. So I can write it here del cross A, which is curl here, that is equal to I, J and K del by del of X, del by del of Y and del by del of Z. And this is A1, A2 and A3. Right?
Yes.
Now here, this one I have to write it here, expand it. I times of this and this cancel here. So del of A3 by del Y minus del of A2 by del Z. Okay? And so on for J and K. So you don't have to write all the things, just to write summation of this one only, because I know that if I will write for I for this one, J and K, so on it will comes. Getting?
Yes, sir.
So now you can write it here for this one. Curl of, you have to find curl of A. This is already curl here. Again I am finding the curl. So curl of A. That meaning is there here. That is I, J and K. For the place of I, this one del by del of X, del by del of Y, del by del of Z, right? Now curl of A already you got it, this one here. In the place of I, this one it will come here. Del of A3 by del Y minus del of A2 by del Z, right?
Yes,
in the place of Y, what we write, this and this will cancel here. So del of A3 by del X minus del of A1 by del Z, right?
Yes, sir.
Similarly, in the place of K, what will come here? Del of A2 by del X minus del of A1 by del Y. Okay?
Yes.
So now if you write it here, this only just write the item. Summation of I is equal to this and this will get cancelled here. This one with respect to Y once again you have to do. So it becomes double directly I am writing here del square of A2 by del X. Okay, del by del X minus del square of A1 by del Y square, right? This into this minus this into this. So minus here del square of A3 by del Z del X minus will become plus here del square of A1 by del Z square. Understood?
Yes, sir.
Similarly for the I, J and K. So now this one is what I, if you arrange it here. So what you can write here? I, if you arrange it, you can write it. I got it for the power 2. Power 2 is how much you got it? This one and this one, right? I. Getting? I can write this one arranging the del square of A2 by del Y del X plus, so this one is what minus here, plus del square of A3 by del Z del X minus del square A1 by del Y square, and minus if I take it common here also, plus del square of A1 by del z square. I can write it.
Yes, sir.
So now here I we got it, this one here. I we got it del square of a by del x square.
Yes, sir.
Now add and subtract the writing here. Add and subtract summation of I del square of a1 by del x square. So what you will get here? This will be the your add it this one here. So you'll get it del square of a1 by del x square plus del square of a2 by del y del x plus del square of a3 by del z del x minus summation of I, here you have to subtract it. So becomes del square of a1 by del x square plus del square of a1 by del y square and del square of a1 by del z square. Getting?
Yes, sir.
So you can write it here. This one is double differentiation. Okay. So del by del of x you can take the common here. So you'll get it del by a1 by del x plus del of a2 by del y plus del of a3 by del z minus this is double differentiation. A1 is given here. So you can write del square del x square del square del y square del square del z square and a1 you can take outside. That all is summation of I. Getting?
Yes, sir.
So this one what you can write here. This is with respect to x for the divergence, right?
Yes, sir.
Write del by del of x summation of I, and this is the divergence of a. And this is double differentiation, so I can write it here del square of a of I. Getting?
Yes, sir.
Del square of a1. So similarly for the whole you can write it here. This is the gradient of divergent. Because divergent of any vector is what? Your that is the function only, scalar function. So this is that's why this is a gradient only, okay?
Okay, sir.
Minus del square of a. So overall you can write it here. Gradient of divergent of a minus this is the double differentiation, here partial differentiation with respect to x. This is the RHS. Any doubt in this? For the identity is given divergence of phi of a vector. Phi is the scalar and a vector here. That will be phi into divergent of a plus gradient of phi into a vectors. We also can write here del of phi into a vector is equal to phi into divergent plus gradient into a vector. Okay. So let's consider a is the vector which is given here, which is a1 of I plus a2 of j plus a3 of k. Okay, so this is the this vector here. So you have to multiply with the phi. Phi is the scalar functions here. So phi into a vector if you do. So phi is the scalar, so you have to multiply with each terms. Okay, so you can write phi of a1 of I plus phi of a2 of j plus phi into a3 of k. Yeah, also we can write here summation of phi of a1 I. The summation of I am writing the I terms. So in this one, now divergence of phi of a is equal to, we got a del into phi of a. So now we can write it here. Divergence of phi a vectors, that is equal to del into phi into a vectors. So what to write here? Summation of del by del of x. I am doing differentiation with respect to x items only because we are taking only items over here. So it becomes summation. This one into phi of a is this summation of phi into a1 of I. This is this one here, and this is this one here. So now here summation of del by del of x, I becomes 1 here. I can write phi into a1. So here this is a product rule you have to apply here. Phi into summation of a1 by del x plus this one I can write it here del phi by del x into a1. So that is only the divergent of phi into a. I can write it here. Phi is the this is phi as it is only, and this is a1 means divergence here. So divergence of a plus this is gradient here. So write a gradient of phi into this is a vector because this is a1. Similarly, if you do for j and k will come a2, a3. That is what a vectors. Next fifth identity is given here. Curl of phi of a vector is equal to phi into curl of a vector plus gradient of cross gradient of phi cross a vector. Okay. We also write mathematically here del cross del phi of a phi of a, that is equal to phi into curl vector plus gradient of that cross of a vector. Getting? So we know that here we know that phi is the function only. Phi is the function in term of xyz. We already know that. And what is a here? A is the vector here. A1 of I plus A2 of j plus A3 of k, right?
Yes, sir.
So we can write it here phi into A2 multiply here. So phi have to multiply these terms. Phi into A1 of I plus phi into A2 of j plus phi into A3 of k. Getting?
Yes, sir.
For this one you have to find the curl here. So curl del cross phi of a vector means the determinants of I, j and k del by del of x, del by del of y, del by del of z, and vector is what here? Phi a1, phi a2 and phi a3. Getting?
Yes, sir.
So now here we can write it here I times of summation of only I will write for the I. Okay? Okay, only I will write it. This into this cancel here, this one. Del of phi of a3 by del y minus del of phi a2 by del z. Okay?
Okay.
So now if you write it here, summation of I, we know that this is already we have proved now only. This formula is phi into a3 is we already proved now only. Phi into delta of a3 by del y plus del phi by del y, that a3. Okay? Product rule. Similarly for this one also, phi into del of a2 by del z plus del phi by del z into a2. This one. Getting? Phi into summation of delta of a3 by del y minus del of A2 by del Z plus del phi of del Y A3 minus del phi by del Z A2. That whole is summation of I. Getting? Phi I taken the common for that. Getting? So this is phi here, and this is called as what? This is actually your curl only, when only I term is given. So this is the I, J, K, del by del of X, del by del of Y, del by del of Z. This is A1, A2, and A3. Only I terms given, that's why this minus this is given. Plus here I, J, K, del by del of X, del by del of Y, and del of Z. And this is A1, A2, A3. This one here. So you write 5 times of this one is what? Cross product, which is del cross A. And this one is 5, you multiply that, so it becomes this one is a del phi by del X. Del phi A3 minus del phi A2 given. So this is called as a gradient of A vector. Getting? So this is the understood?
Yes, sir.
This one.
No, sir, upside that. From here, sir.
This one I written only I terms, right? This into this, minus this into this.
Okay, sir.
And this one expansion now only we have proof, right? Phi into A3 if you given, then what you can write? Divergent of phi into A. This one, no, phi into divergent of A, gradient of phi into A, right? This property I have used here. Phi into A3 is given, so phi as it is only A3 plus phi differentiation A3 as it is. This product rule minus phi A2 plus del phi by del Z A2. Getting?
Okay.
Now I have taken here this terms and these terms together.
Separated, sir.
Separate this one and this one is separate.
Okay, sir.
So I can write it as phi if you common here in this. So this one is the just cross product curl.
That is.
And this is del phi by del X given here, and A3 minus A2, which means that is also cross product here, which is only I terms is given. So 5 times of this is called as divergence only. Okay, because is given here, curl called as because it's cross product here. Determinants given curl here, and this is also a curl only, but in the del phi by del X. Okay.
Okay.
Now sixth identity also I will do it, then you can go.
I'm writing, sir.
Last identity, sixth one is if given divergent of A cross B, that is called to criteria B cross B dot curl of A minus A vector into curl of B. Okay? Yeah, mathematically we can write here del of A cross B, that equal to B cross B dot del cross A minus A into del cross of B. Getting?
Yes, sir.
So here we know that A and B is two vector here. So I can write here A is equal to A1 of I plus A2 of J plus A3 of B. And B vector is equal to I write B1 of I plus B2 of J plus B3 of B. Getting?
Yes,
So A cross B means two vectors there, you have to find the determinants here. I, J and K. A1, A2, A3. This is B1, B2, B3. So only I terms, if I write it here, I can write it here. Summation of I into this cancel. A2, A3, A2, B3 minus B2, A3. Right?
yes, sir.
Now I have to find the divergence of this one. Divergence of A cross B. I have right here del of A cross B. Right?
Yes, sir.
So here also I have to take only the I terms. Del by del of x, I will write it. And this is also I here, the summation of I, A2, B3 minus B2, A3. Correct?
Yes, sir.
So here if you do I put is become 1 only. So that is the summation of del by del of x, A2, B3 minus B2, A3. Okay? Now expand it here. This is also product rule only. Okay? Summation of A2 del of B3 by del of x plus B3 del of A2 by del x minus A3 then B2 by del x minus B2 del of A3 by del x. Getting?
Yes.
Now if you expand it here, write A2 B3 plus B3 A2 del B3 by del x plus B3 del of A2 by del x minus this one is del of A3 del of B2 by del x minus B2 del of A3 by del x. Getting?
Yes, sir.
This is for the I. Similarly for the J and K you can write it. I'm writing for the whole A3 by del of B1 by del Y plus B1 del of A3 by del Y minus A1 by del of B3 by del Y minus B3 by into del of A1 by del of Y plus A1 times of del of B2 by del Z plus B2 into del of A1 by del Z minus A2 by del of B1 by del Z. Just I'm writing for the all, okay?
Okay, sir.
Del Z. This one will get it here. So you can write here now. This is in the expansion form. You can write here summation of B1 del of A3 by del Y minus del of A2 by del Z minus summation of A1 del of B3 by del Y minus del of B2 by del Z. Okay. This one is the B1 if you take the common in the part of this, and this one only. Okay.
Yes.
So now here this one you can write delta of B1 I and that is the determinants here. Okay. So this is del cross of A minus A into this is the determinants of B. Okay. So
Okay.
overall you can write it here that B into del cross A vector minus A into del cross B vector. Okay, this one.